Welcome to Shirtless Talker Physics Equation Solving with me, mass on a slope. Now, let's get in a little closer for our triangle. Right here, we of course have our mass on a slope. We have a force going downwards, down the slope, and that is going to be the mass times gravity, sine of theta. Why is it sine of theta? Well, it's just going to be the sine of the angle here. The angle here is theta. Then we of course have the actual slope, and it's acting through the slope. This is just going to be mass times gravity, cosine of theta. And of course we have the mass times gravity of it just acting on this one. Now, if this thing is stationary, friction is going to be mg sine of theta. Friction right here. But take, for example, it's at a constant speed. If it's at a constant speed, then mg sine of theta is going to be tension. For example, if it is on a rope here. So if the mass is on a rope, then tension is going to be mass times gravity sine of theta. And what if it's accelerating, for example? Well, if it's accelerating, then tension is just going to be mg sine of theta plus the mass. So, let's go into a few examples, and we can, of course, back up here. Take mass on a slope with this example. The angle is 30 degrees, it has a distance of 200 meters, and the initial velocity is 0. Let's first understand and calculate the acceleration. Well, the acceleration of the actual triangle, the block itself is just going to be x, so we'll take f of x and we can equate it to the force of gravity. Because the force of x is just going to be gravity, this thing's initial velocity is 0. Once we equate that, we can understand that the masses right here, they are going to cancel out. Because we can equate the acceleration equal now to gravity times sine of theta. And this equation gets a lot easier because you don't even need to know the mass. We canceled them out. We have the acceleration of x equals the gravity times sine of theta. Well, gravity is a constant that we know, it's 9.8. The sine theta is just going to be sine of our angle. Our angle was 30, so we take sine of 30, which is 1/2, and when we take 1/2 times 9.8, we learn that the answer to this acceleration is right here, 4.9 meters per second squared. But there were two questions here. Two questions. The second question was asking for the final speed. Well, we just take the distance, which is of course given to us in the equation. The distance is 200 meters. The acceleration is 4.9 meters per second. We already calculated that. We have the initial velocity, v0, which equals 0, and we need to calculate the final velocity. What equation do we know that solves for this? Well, of course, the equation we know is the final velocity squared equals the initial velocity squared plus 2ad. And once we just plug and chug, we will, of course, get the answer. All we gotta do is plug and chug. The final velocity, what we're solving for, equals 0, because that's the initial velocity squared, plus 2 times ad. A, of course, is 4.9. We calculated that right here. 4.9 meters per second, don't forget the units, and distance is 200. Once we plug these in, we get 1962 times 4.9 times 200, and because this is squared, we just have to take the square root. Once we take the square root, we understand that the answer is 44.27. This has been your physics lecture of the day for Mass on a Slope. Make sure to send this to someone who needs to brush up on their physics. And I hope you have a good rest of your day.